Good morning, ladies and gentlemen. Welcome to this parallel session on multimedia architecture. My name's Shirley Wood. I'm the Customer Support Director for UKERNA, which is the organisation that runs Janet in the UK. And can I also say welcome to any people watching us remotely on the internet. This session will be looking at several different multimedia architectures being used on the internet and the implications of their use. As we've got three fairly different presentations, what I'd like to do is have each presentation then take questions after each session. As we've got a packed session, I will progress quite quickly so that you all get out to lunch at 12:30. I don't know what the football is today. So our first speaker is going to be Roger Bolam. He's the video development engineer at UKERNA, and he's involved in all aspects of video conferencing within UKERNA. He's also managing the Janet IP video conferencing service EU procurement. And Roger is going to talk about the deployment of IP H323 within the Janet community. Roger.
That's on. Okay, well, good morning, everyone, and thanks for coming to this presentation titled Deployment of IP Video Conferencing. There's a slight change to the way that the presentation is going to be laid out, as Steve Williams can't unfortunately be with us today. I'm Roger Bolam. I'm Video Development Engineer at UKERNA. I work in the Advanced Technologies Group within the Network Development Division. A little bit of a placeholder about UKERNA and what we do in a very small nutshell. We provide internet services for UK academic and research institutions. We provide connectivity to the joint academic network within the UK, and this is currently a 2.5 gig backbone with a 10 gig upgrade coming in the next couple of months, hopefully. Okay, a brief outline of the presentation today. I'm going to talk a bit about the video conferencing history of how we've got to where we are today. I'm going to talk a little bit about the pilot service, which we're supposed to be launching tomorrow, which will be quite interesting. I'm going to talk a little bit about what that service is made up of, what it can do, and the specific architecture and components of that service. I'm going to talk about the timescales of the way we're deploying this pilot and turning it into a full service, and the requirements upon ourselves and the users of the video conferencing service, what they need to do to get the best from this service. Okay, we've had a centralised video conferencing service to the Janet community since 1997. This has used traditional ISDN and ATM technologies. The ATM has predominantly been used in Scotland, the Scottish Man's Video Conferencing Network, and we've been using ISDN within England and Wales and whatever. It's worked so far. Call charges, particularly with ISDN, have been a bit of a barrier to the growth of video conferencing, and to try and counteract that, we've been doing a bit of research into IP video conferencing for the last 5 years. The first two projects were the PipVic and PipVic2, which is piloting IP video conferencing, and surprisingly piloting IP video conferencing 2. Both of these research projects, feasibility studies, whatever you want to call them, proved that really 323 as a protocol was a bit immature, and we weren't in a multi-service environment suitable to deploy IP services end-to-end. It wasn't really a scalable service at the time, so we took a few steps forward. Based upon drivers for IP video conferencing, we looked to develop a pilot. The main reasons of this is the new Super Janet 4 capacity, well, the new as in last year new, of 2.5 gigabits. This allowed us to seriously think about deploying a centralised service with enough capacity to try and support real-time applications, general high bandwidth usage. Another rather large driver was the closure of the ATM networks in Scotland. These are now end of life. The Scottish Man's Video Conferencing Network, unfortunately, have had to switch to IP, as they don't have a supported network or supported codecs anymore, and they've recently procured some IP codecs, and their ATM officially switches off on the 1st of June, but they've had a month's lag there. So we're providing this limited pilot service initially for that. Also, some of you may have heard of the Welsh Video Network, or the WVN as it's been called. The IP developments within that. It's traditionally an ISDN stroke IP service to 80 FE and HE studios within Wales. It's a UKERNA Commission project. We've been involved in it from day one and pushing that. And we're now trying to learn from WVN and Scotland and try and pull together a UK-wide service to provide a service to everyone within the UK as opposed to specific pockets. We've also seen a driver from the community. I've got an IP codec, can I use it? I've got horrible net metering, can I use that? The answer is obviously no for that. IP is becoming more widely deployed and people have a PC, and effectively if you have a PC you have a 323 endpoint, which has driven us forward to try and develop this service. Okay, so more recently we've undertaken two major projects. The VIP demonstrator, which was mainly a feasibility study again, but we knew we had the bandwidth, we knew that the equipment was possibly mature enough to be deployed and to be trusted. It's not going to fall over all the time. This looked at several areas to do with video conferencing, from usability and human factors to security to multi-point gateway operation, and a few different things. And we looked at specifically at trying to provide low-cost, to provide support for low-cost endpoints such as net metering, white pine, CUCME, whatever you want to call them. And as that came that, we actually realised we couldn't do that at the time. In July last year, we started up the 323 architecture group, which involved representatives from UKERNA, from our UK community, and from commercial companies, Cisco, and a couple of other service providers. And this was to make recommendations to ourselves, to UKERNA, on how we're going to build the architecture of this video conferencing service, and also to try and get across to our users what they had to do to use this service. It's not, although it's an internet-based service, you've got to do a little bit more than just plug and play, really. It needs a little bit of network engineering. I've just finished, well, just about finished, an e-procurement for these centralised service components. We do have a few MCUs and other bits and pieces deployed on Giant at the moment, which we're starting the pilot for tomorrow. And these centralised service components will significantly increase the capacity of the video conferencing service and hopefully the quality. And these are going to be hopefully deployed at the end of July of this year. And this brings us on to the pilot service, which will, as I say, officially launches tomorrow, but is only small at the moment. Okay, so the architecture of the service, it's going to be a centralised service as we're trying to provide it to all of our users. We're locating the equipment in CPOPs, which are core points of presence. It's housing on our network. It's where all the routers are housed and the networking equipment. And it's going to be managed and used remotely by the Janet users and by whoever else wants to use it. It's going to be made up of MCUs, gateways and gatekeepers, dependent on the outcomes of the procurement, which I couldn't talk about. We're also trying to include in that an automated booking system. And we see at the moment a few barriers with the current way that we try and book a video conference. It's not really the best way that it could be done. And again, it could be a barrier to people not using it because they're a bit, I don't really want to do it that way. I just want to call someone up and have a video conference, or I want to sit in a room and everything happens automatically. We're trying to make sure that we respond to our customers' requirements. And obviously, with it being a remote service on an IP network, security and resilience are slightly vital to the service. Here's a small, well, rather interesting picture of the Janet backbone, and it's these yellow circles are the CPOPs. We're initially going to locate some equipment in Reading and Leeds, and these CPOPs are fed by the regional area networks, which then feed our universities. So effectively, the backbone here you see in the ladder, these 8 points serving the backbone, it's almost collapsed because it's such high bandwidth. So we're viewing it as I think this morning's talk was about, with more of a kind of reverse of that, where we're trying to provide a core service and the end users use that. But anyway, that's video conferencing for you. Oh, I forgot to do that one. Sorry, that shows the core equipment, that lovely red circle. The capability of this service, well, obviously, people want video conferencing. Their expectations are that they sit down and they see a television or a screen. They don't necessarily see themselves, but they want really good quality video conferencing. They want to be able to, they don't want to care about problems with the network and the way that affects pictures. They want to, their expectations are automatically high because we all sit at home and watch television for a lot of our lives. Well, I do anyway. We're going to offer the service on an MCU initiation basis, where people will effectively sit in a room. As long as our codec's switched on, we'll do all the work behind the scenes. You sit down and we dial out from the MCU. This removes the need to distribute numbers, which has been another barrier to the usage. We have a real problem with getting numbers to actual users on the ISDN front. And users don't then need to know how to operate codecs. I mean, a lot of people at universities, although they are very technologically aware. Operating a codec is not the easiest of things at times. So we're just trying to make sure that we can provide a service to everyone and we're not having any barriers whatsoever. We're going to gateway the service. We're going to offer a matched IP to ISDN gateway service at the moment. We see ISDN continuing to grow or remaining as it is, and possibly the introduction of an IP video conferencing service actually bringing some ISDN users out of the closet and starting to use their technologies again. If we can mix the two, yes, there's call charges, but it'll still work. We're also we're going to offer a centralised gatekeeper service. I'll talk about this a little bit later on. It's a bit unclear why we're doing that. But effectively, as part of the architecture group, we said that to use this service, you must be registered with a gatekeeper. I'll talk about gatekeepers later. But we don't want to make sites have their own gatekeepers from day one because it's a bit of a hard box to manage. It's not the easiest of things. So we're offering a gatekeeper service on the core of the network that you can register with, and effectively you don't have to buy any more components to architecture your campus network. So the MCUs are offering 2 megabit operation for up to 48 IP sites. 2 megabits at the moment is really the only call speed we can offer core services for. There are talks of 4 megabits and obviously the HD TV quality, whatever you want to call it, after that. But 2 megabits is the standard at the moment. When I first started, it was 384 and then 768, and now it's 2 meg. So yeah, this is for 48 IP sites. The transcoding on IP between 384, 768 and 2 megabits. This is mainly... There's been problems before with video conferencing with low-end users trying to match with high-end users and transcoding problems, and always the video conference becomes effectively the quality of the lowest endpoint in that video conference, and we want to remove that. So this way we can transcode between the sites and we don't have any problems. We want remote management and scheduling of the MCU resources. We don't want our operators to have to receive email notification of I'd like a video conference, I want it at this speed, at this time. We're trying to automate the booking process, and a user effectively books the MCU resources without knowing it, and the MCUs automatically initiate the calls. So this way, the ops guys are left to do monitoring and fault finding. Hopefully there isn't any. But yeah, we're trying to make it more of an automated process, and again, the automatic conference initiation, which is the dial out from the MCUs. The gateways, as I talked about earlier, we're going to continue to use ISDN. We're matching our ISDN to IP capacity. We're hopefully going to deploy a chassis-based MCU solution. So as we have IP and ISDN cards in that chassis, as the ISDN starts to filter off and people aren't using it, we can pull out the ISDN cards and stick in new IP cards, which aren't really that expensive. So as the service grows, we can mould our model around that. Okay, gatekeepers. I'm telling you now about the gatekeepers we're going to deploy, but on the next couple of slides I'm going to talk a little bit about why we have gatekeepers and what they do. To support international dialing and to manage our own internal UK endpoints, we're deploying 3 levels of gatekeeper, an international, a national and a site. And this is part of supporting an international dialing plan which has been developed with ourselves. WVN, SurfNet and VidiNet are going to adopt that as well, to make sure that we can all the worldwide NRNs can talk to each other using a dialing scheme and using a gatekeeper hierarchy that's standardised across the board. The global dialing plan. When we came to develop a video conferencing dialing plan, taking ourselves away from this IP address theory and having a structured and meaningful number that we could dial in, that we could put a 323 identification alphanumeric tag to, so you can have a Roger at UKERNA, .video.j.net. You don't have to dial a number that means nothing to you anymore. So behind the scenes we developed what's known as an E164 number, which is part of the 323 standard. And for the UK, an example would be 0044, then the green numbers, and then the blue numbers. And the hierarchy of gatekeepers we have, this international, national, and local gatekeeper, effectively reads these numbers and routes the call appropriately, depending upon the number string. So we have a way of knowing where the call's from, where the call's going to, from a national to a regional and to a local basis. So this way we can control where calls are going, and we don't have to rely upon IP addresses. Local gatekeeper functions. Now, all our gatekeeper on the higher levels provide dialing services for us. Local gatekeeper services allow you to control 323 endpoints at your campus. You do this by creating a zone, which is effectively like in the telephone world, an STD code. It's limited by the number of endpoints connected to it. and this is seamless of network architecture. You don't have to be within the same room or the same network. I could have a gatekeeper in Oxford and somebody could have an endpoint in Edinburgh, and they could register with my gatekeeper and we become one zone. These gatekeepers, their access control, bandwidth, things like that are all based upon what's called management criteria. And local sites create this management criteria. I mean, if I was a network manager at a university, I wouldn't want anyone with a PC to become a 323 endpoint and start doing 2 megabit video conferencing on my local LAN. That'd be a bit of a nightmare, really. So these gatekeepers are designed to control the 323 traffic. As a manager of the gatekeeper, I can say who's going to join that conference, who's going to use the service, and I don't want rogue endpoints on my network. So by blocking that on my access list, firewall, whatever you've got, and insisting that calls are set up by this gatekeeper, excuse me, I can make sure that I know what's going on in my network and that people aren't soaking up my bandwidth. Another function of video conferencing is that 323 is a standard. For some reason, they deployed it without thinking anything about firewalls. And 323 doesn't work with firewalls. It works on a random port address basis. So obviously, if you've got a firewall, you can't open sections of a firewall. You've got to open the whole thing, or a very large range of numbers anyway. So Cisco, the only people we know at the moment that developed this proxy solution, developed a video conferencing proxy, which also acts as a gatekeeper, which is quite handy. And this effectively pulls or filters all of your 323 traffic from the network onto your LAN, bypasses your local firewall, your internal access router. You don't have to compete with campus traffic on your LAN. So we're recommending to our end sites that follow this model. And the WVN with 86, whatever it is, studios now, have also used this proxy solution. And it's working very well. They're not having any major problems at all. We're recommending to our local sites that they go out and buy codecs, ideally capable of calls between 384 and 2 meg. That's quite self-explanatory. That's the speed of the service, so we don't want you to go under or over. We're saying you must have a gatekeeper of sorts. You must register with a gatekeeper. And we're recommending that you buy your own gatekeeper because it seems a bit strange sites wanting to use our management criteria to manage services that their campuses are going to be accessing. It's almost like creating a separate video network, but not creating a separate video network, if that makes any sense. Probably not. We're also, again, recommending the proxy server or 323-aware firewall for security reasons. To do video conferencing, we have to either, at UKERNA, we had to switch off our firewall, which we weren't going to go and do, or we had to, each time we wanted a video conference, put that specific IP address and allow it in certain ports to allow the video conference to take place. Now, this is a real restriction to use. So to make sure you can video conference on your campus, it's proxy server, 323-aware firewall or no firewall whatsoever. And obviously, suitably provisioned Janet access. If you're going to have 10 codecs on your site, you obviously have to make sure that you've got at least a 10100 connection into your regional area network. We don't want to take up everyone's campus bandwidth by video conferencing. Obviously, internet services are still predominantly email, web-based, whatever you want to do with that. Here's a traditional, well, not a traditional, a very simplistic LAN architecture, the way that we're recommending to our sites, how you engineer your networks to get the best use from video conferencing. Here's a normal way we connect up an endpoint through a switch into the internal router, into the firewall, which would have to be 323 aware in this case, which is that one, and then out into the big wide world. And it's the same again when you're bringing in a WAN link, ADSL, ISA, whatever you want to call it, whatever you're going to be routing through your IP network. Again, you've got this problem with your institutional firewall and competing with your campus traffic. And the 323 proxy effectively soaks or pulls the 323 traffic from your network on inbound and outbound and controls it. And the 323 proxy is also quite good for QoS. The endpoints behind the proxy, their IP addresses from a QoS point of view are hidden, and each IP address from the endpoint, the E164 numbers, as I mentioned earlier, are different, but the IP address remains the same as the 323 proxy. So providing QoS on an IP address to IP address basis, this is easier because we have to provide it to one proxy as opposed to several or multiple endpoints at campuses. And that brings me on to lovely quality of service. Well, real-time applications do benefit from QoS. If you received an email a couple of seconds late, you probably wouldn't even know if that email had any problems. Again, with internet browsing, oh, it's a bit slow today, it's not a problem. With real-time applications that depend on packets arriving at specific time spaces and and the audio and video being synced, we really have to have a really small latency jitter measurement. It's got to be very, very small. To try and get around this, to try and develop a QoS mechanism that's suitable for our general internet traffic and for video conferencing and other real-time applications like streaming, UKERNA developed the QoS think tank. As an outcome of that, we're now prototyping some QoS mechanisms on Janet, and at the moment it's IP premium using diffserv-EF. And the important thing for video conferencing and for any QoS is that it must be end-to-end. It's got to be from our core service to the end user, otherwise there's just no point having it there. Okay, to use our service, to use the video conferencing service that we're going to be deploying, as in the ISGen world, sites have got to be fully quality assurance tested to make sure that the audio and video quality is of a standard as such. Sites must register with a gatekeeper, and conferences must be booked using the Janet booking system that we currently have, and we're looking to buy a new one because it's a bit old-fashioned. To benefit from the dial-out services, the MCU services, gateway services, whatever you want to use, we must know that you're going to have that video conference when that video conference is taking place, and you must allocate the resources to your sites. So we're not magicians. We don't know. We can't predict when you're going to be having a video conference. However, point-to-points, if you don't want to dial out from the MCU, if you just want to have a point-to-point between yourself and Joe Bloggs, that's absolutely fine. Just don't use the booking system, and obviously you won't be using the services. The current booking system we have, the booking system is actually a really important part of video conferencing for us. It's effectively the portal to the video conferencing service we offer, and we want to make sure it's very easy, very straightforward for users, for operators, so that we don't have any boundaries limiting how the video conference can take place. And we want to make sure that people are happy with the booking system, which they currently aren't, and we do have a lot of feedback saying your booking system is not any good, we don't want to take part in this service, it's just a waste of time. We have an in-house developed ISGen ATM booking service, which we developed at the University of Edinburgh. I've been involved in the development programme for the IP service. We're currently we're going to be evaluating commercial booking systems as part of the procurement. This is the step towards this automated booking process. At the moment, it's just a web form with an algorithm behind it, knowing the value of the MCUs and the value of the gateways and what resource we have and what's already been booked. And the ops guys manually have to book on each MCU, and if we want to do dial out, they've got to initiate that conference. As I keep saying, we're trying to remove that with this automated resource booking and resource scheduling, as it's become called. Okay, a bit of timescales about when we're going to be deploying this two-stage pilot service, and when we're looking to offer a full service to the Janet community. I know that a lot of the UK community are getting a bit sick of waiting for this service and saying, well, I'm just going to go out and buy my own endpoint, and I'm going to call whoever I want to, and I'm going to buy an MCU and do this. Now, that's great. We encourage that. And what we're looking to do now is we're at a stage where we've developed this service, and we can start bringing on board these pockets that people have gone out and developed their own stuff. But it's a lot easier to offer a service on a small scale as opposed to a national scale. And we've got service level agreements and things like that behind it, which make us have to think a lot about what we're doing. This limited pilot service is starting in June 2002. That's tomorrow. We're going to have a contract placed for the major service components I've talked about, these extra MCUs and gateways and gatekeeper resources. So that's going to be deployed in July and August, and anyone can use that service. The pilot service is going to be open, but it's going to be based on, if you use it, can you give us a bit of feedback and let us know how it went. And with a view of deploying a full service late this year, early next year, we're going to hopefully hand the development of this service over to our service division. And as the requirements spiral up, and hopefully we see lots of usage of IP, as I mentioned, we can upgrade our MCUs. We have money there to do it, so it's not going to be one of the fly-by-night service which we're going to deploy and just leave. We've got development plans in place already for that. A little bit further information, if you'd wish, on the VIP project, the 3-3 Architecture Group report, and some of the information about the current procurement we're doing and what we're trying to buy. And this will be updated as contracts are signed and we know what we're going to have. And any questions? And I'll go back to that.
Thank you very much, Roger, for an interesting talk.
Thank you.
We have time for questions. There's one there. Can you wait for the microphone to come up, because we're putting it out on the internet?
Thank you. Roger, one question and 2 comments. The question is, do you do accounting and billing for the gateway services yourself, or do you have another solution for that?
For the gateway services, the ISDN, I actually forgot to mention this in my talk, the ISDN is still dial-out, so the ISDN is initiated from a codec into the gateway. So we don't do any billing, and the IP service is currently free, so the billing's still at the site. Unless we do offer a billing service where we can dial out to them if they want to, but we don't promote that really.
Okay. And the 2 comments are that there is the COM proxy, KOM proxy from the Technical University of Dresden, that we've been using at SurfNet to our pleasure. That's a free one, and source is available even. And the second command is on, of course, the plug for the global dialing scheme, is that you were talking about the international part, and we're very happy that UKERNA hosts the top-level gatekeepers for the international parts. It also means that we have a hierarchy in Europe, that if you have your own video conferencing service and want to make sure that you can easily dial UKERNA service and the people attached to it, that you can contact Steve or Roger, and they will get you up in the international hierarchy.
Or Aegon as well, you can contact Aegon by any means.
Thank you. There was another question I thought I saw in the centre.
Just another plug. I don't know if I'm interrupting someone else, but I'm coming in through A323 to that room. So just to let you show that the global dialing scheme works. I think the picture can come up, but it will take some more time.
Yeah, you're not actually switching in yet.
Thanks for your talk, Roger.
That's
This is
okay.
Victor Rice from HANet.
Hi, Victor. I can't see you, but I kind of recognise the voice.
No, they have to fiddle around still.
It's your right vision
But
deployment,
at least you
Victor.
hear something.
Okay, any more questions?
I was really curious about the budget of the deployment project. That was first question. Second, do you have some solution for small client mobility?
Answer to your first question is I can't go into that, but it's rather significant. To provide 2 megabit services is classed as being leading edge at the moment for some reason, and yeah, it is very costly. But if I talked about that, I'd have to talk about the procurement, and I can't because it's EU law, etc. In terms of mobility, we haven't really thought about that. We're stepping out of the ISDN world where you've got to, in some cases, get into a car and drive to a video conferencing studio to have a video conference about video conferencing, which is quite strange. And we're trying to bring it to a desktop. So you can use a hardware codec in your desktop PC. So in terms of mobility, really, if you have a 3-to-3 endpoint, you can effectively join this service. But in terms of sort of wireless and things like that, we're not taking any steps into that at all yet. Chicken and egg and all that.
Okay, I think we've finished questions here. I'm sure Roger's more than willing to take questions outside of session, so thank you once again, Roger.
Thanks.
Whilst we're moving the microphones across to the next speaker, anyone that's sitting on the stairs at the back, would they like to come down to the front and find a more comfortable seat? And our second speaker is Michael Fromme. Michael studied electrical engineering at the University of Hannover and received his diploma in 1996. Since that time, he has worked as a research staff member at the Institute for Computer Networks and Distributed Systems. His major interests include multimedia systems and group communications in high-speed networks. Michael is going to talk about an architecture of a shared image electronic whiteboard in telemedicine. Welcome, Michael.
Thanks for the introduction. Hello, good morning, everybody. Despite of the small typo in the program, we're talking about shared images, not hard images. And first of all, I want to excuse I'm an engineer. I'm not one of the medical staff in our project, and so I have to rush through the medical introduction. And perhaps I'm missing some points. Please excuse me for that. There's a short outline of my talk. First of all, I want to introduce our project and the conferencing scenarios within our projects. Then I want to show you the network infrastructure that we are building in our project. And after that, I come to the technical part of this talk. I want to talk about whiteboards, whiteboard software, whiteboard functionality, and of the architecture that is used in these whiteboards and the system architecture of this particular whiteboard, of course. In our project interface, we have the topic of maxillofacial surgeries with bone rearrangements. Patients have injuries, for example, or have genetically caused facial abnormalities, and these abnormalities are treated with surgeries of the maxilla, and often there are bones cut and rearranged. Of course, these surgeries are really long-lasting, and often these surgeries too need preoperative treatment by orthodontists to bring, for example, the teeth into the right position by the use of braces, etc. To plan these surgeries, the medical staff uses computer-aided planning tools for the surgery, and these tools are used to validate and evaluate the preoperative treatment process together with the orthodontist and the patient. So there are multiple consultations of the surgeon and the orthodontist necessary within the preoperative treatment process. Our aim is to allow some of these consultations, not really all, and of course not the first one, but some of these consultations to be done with the aid of a video conference. So that, for example, many journeys of the patient and the orthodontist to the university hospital where the surgeon is doing his work will not be necessary, and we try to build a working environment for this case. Of course, we want to evaluate this working environment with respect to efficiency. Thus, do we really spare time, or is this video conferencing solution still to be too complicated for this case? We have practical requirements. We should see if they are met, and we should enhance our working environment towards these requirements. And of course, the experience of the patient is a necessary thing. I want to show you some pictures of this computer-aided planning tool. What you see here on the left is a picture of a girl with chin abnormalities. The chin is at the nose level, as you see here. The girl it has problems to close her mouth. And what we want to do with the surgery is to get the chin back to the head, so that we hopefully get this picture after the surgery. There in the top you can see the computer-aided planning tool. We have a model of the bone structure of the head. This model is derived by radiograms, and we can use tools to simulate cuts and bone rearrangement within this model. There is a video imaging software within this planning tool that allows to render a post-surgery picture, as you see here on the right. Below you see another model of the bone structure and of the things that are done during such a surgery. And as you see on the right picture, this is a post-surgery photo of the same girl. There is quite a good similarity between the proposed video imaging picture and the real post-surgery picture of the girl. As I said, our aim is to do some consultations with the orthodontist and the surgeon by video conference. So we need some equipment at the orthodontist side. Many orthodontists already have a tool which is called an intraoral camera. That is a very small camera, like a pen, in a pencil size. And this camera can be used to make images of the teeth from inside the mouth. And typically these images are displayed on a computer screen which belongs to the camera system. What we are doing is that we are equipping the orthodontist with a video communication terminal, like the one you see here below. It's a standard H323 endpoint which allows about 1 megabit data rate and has a fairly good quality. And what we also do is that we equip the orthodontist and, of course, the surgeon with our whiteboard software. The whiteboard is needed to transfer and share images. For example, these images can be radiograms, can be images of the model, as you see here, or can be still images which are captured from the intraoral camera and are loaded into the whiteboard. Of course, it is also possible to transfer a live video stream from the intraoral camera by the means of the video communication terminal. This is a very small outline of, a short outline of our communication structure. We have the orthodontist side. We have 2 orthodontists in our pilot project. Both are located in Munich. And on the other hand, we have university hospitals. We have 2 university hospitals in our project in Munich and in Düsseldorf, and we have another hospital at Stuttgart. And we are connecting the orthodontists and the university hospital with an H323 infrastructure, which has some similarities as the infrastructure you've seen before, but is, of course, not so sophisticated. In Hannover, we are running a Gatekeeper, of course, and 2 MCUs, and we use one of these MCUs for these video conferences. These video conferences in this picture are peer-to-peer. You have 2 parties, but normally in our conferences there are more specialists within one consultation. For example, if one specialist wants a second opinion for a problem, and of course the technical stuff like us in Hannover, we are also watching these pilot conferences. So we have to use an MCU. In reality, this is a multi-party conference all the time. For the whiteboard, we have also a multi-party conference with a whiteboard. We use a whiteboard server, and I come to this point later. The overall network infrastructure is really simple. The university hospitals, Munich and Düsseldorf, and of course the University of Hannover and the Fraunhofer Institute, formerly known as GMD, in St. Augustine, are connected to the German research network, which operates in the gigabit range. So this is very easy to interconnect these sites. On the other hand, we have orthodontists that are living in the Munich area and the hospital in Stuttgart. And these parties didn't have an internet connection that we were able to use. So what we did in this project was that we equipped these sites with an SDSL internet connection of 1 megabit speed. And the interconnection of this internet provider network and the German research network is via the DE6 and DFN exchange point. Okay, after the introduction, let's come to the whiteboard functionality. Of course, a whiteboard is something like an image viewer software. We are able to load and display common file formats, and we are able to load more than one image into the whiteboard, as you see here, and we are using these different images as pages. We can switch between the image to display one or another. One of the great things of whiteboards are that you are able to do image annotations. You can draw simple lines on the image, you can write text on the image, you can highlight areas, or you can just have some pointers to point to areas. And this is important for using this software in video conferences, where you need to act with something like a piece of paper. You're doing in a face-to-face conference. You can point to areas or you can highlight areas. These annotations are not part of the image and do not obstruct the image, of course, and they can be moved or deleted without destroying image information. Another point that has to do with the image viewing is, of course, zooming, scrolling the image, or doing some color manipulation like saturation or luminance enhancements. And these manipulations are done local at one whiteboard, but it is possible to synchronize all other views of the same image, of the other instances of whiteboards in the conference, with the view of the speaker, for example. So that you can be sure, if you want to point to some area in the whiteboard and you synchronize the views of the different whiteboards, that everyone sees the same area of the picture that you see. Yes, we have some technical functionality. Of course, we have a session management. You can see the participants that are using the whiteboard in this session right now, and of course, we can print and save images. But another interesting point we have implemented is color management. I want to introduce color management with a few words. If you look at these input devices for images, then you find very different techniques to produce the rasterized image data from the real image. We have scanners, we have digital cameras, we have different CCD chips inside these, and so every device has a different characteristics to produce the data from the color. The data then is transferred to the computer, is loaded, for example, into the whiteboard, and might be transferred to another computer. And obviously we want to see this image. We want not only to store it and to transmit it, we want to visualize this image after all, and so we have screens or printers. And the same thing that I said for input devices applies to output devices as well. We have very different technologies. We have here different types of printers. We have different types of screens. We have TFT displays or CRTs. And every of these output devices has a different characteristics to reproduce color from the data. And what we do need is that we have an additional processing to achieve a true reproduction of the color. And this processing is done by a thing we call color management system. How does it work? We have the input device, and we have a name for this color space that this input device is able to handle. We call it is a device-dependent color space. When it comes to the process of loading the image, we have to transfer this device-dependent color space into a device-independent color space, which is independent of the characteristics of the device. And therefore, we need some description of these characteristics. And there are input profiles which can be generated by special software, which are describing the input characteristics of the color scanning process. And using these input profiles, we can get a picture without these errors that result from the different characteristics. And so we achieve a device-independent color space, which can be any color space which is able to handle the information. So these colors must not have to do anything with the real color. On the other hand, we want to see the true color in the reproduction. So we do the same thing at the output side. We have profiles that describe the characteristics of the output device and are able to do a transformation from the device-independent color space to the device-dependent color space using these characteristics of the output devices. And so we can reproduce the color with less error than it would be if we do not use these transformations. Within our whiteboard, we use a color management facility of the Java Advanced Imaging API, which can talk to the color management facilities of the operating systems like Windows or like macOS. And when we load an image, we load it together with an explicit input profile. So that each image has a description of the input characteristics as well, and we can do the transformation. to the device-independent color space. And images are stored and processed and distributed within the device-independent color space as RGB, which has been defined by Microsoft and Hewlett-Packard, as I think. Okay, some notes for this. Of course, we need accurate profiles for the input and output devices to achieve a correct transformation. And it is possible to generate them with special measurements software and a so-called spectral photometer. You see this device here, it's a picture, and a special calibration software. The good thing is that many manufacturers today are providing profiles for their devices, that these profiles have the characteristics that are built into the device. It's that they are not calibrated, so that we have a light color mismatch, but at least the characteristics which the manufacturer built into the device is known by this profile. Okay, after all, we come to the architecture of the whiteboard in more technical terms. Of course, we have multi-point conferences with the whiteboard, and we do need some protocols that allow us to facilitate this group communication. There are two possibilities at least. One possibility is to use IP multicast. IP multicast is a very efficient mechanism to distribute data packets from one computer to a group of computers, and we have built in IP multicast protocol into our whiteboard to use this mechanism. The bad thing about IP multicast is that it is only working if the network you are working with supports IP multicast. And this is a real problem as well. In our case, there are two mechanisms that are barriers for IP multicast. On the one hand, we have the access networks with the SDSL links. These networks do not provide IP multicast service because the internet provider doesn't want it to. And the other thing is that the university hospitals, of course, use firewalls. And firewalls are a big barrier for IP multicast. And so within the internal networks of the university hospitals, we are not able to use IP multicast to communicate with other sites. So what we need is another option, and the other option is fairly simple. We have a centralized server. This server uses TCP connections to connect with the client, and we need this server, of course, for the SDSL connected partners and for the partners behind firewalls. Within our multi-point protocol, we have some functionalities that we need. We need, of course, session handling. We need to know which computers are within our communication group at the time. And, of course, we need reliable transmission. We are transmitting images. These images can be really large in the megabit range. And we should be able to transmit them without errors over our communication protocol. And there is one thing that we call startup synchronization or image bootstrap process. If you imagine there is a conference using two whiteboards, for example, and they have images they are already using, and these images are already loaded. If you have a latecomer, a third party that wants to join the conference, this latecomer has to choose one of this instances in the old conference to get the image data. And we call this process the image bootstrap. Okay, this is a small overview of the system architecture of the whiteboard. It's based on Java technology. This has the advantage that it runs on multiple operating systems. The image handling part is really similar to an image viewing program. We use the Java Advanced Imaging API, the Java 2D API, and of course have our own image handling code. On the other hand, we have here the network section, which is a bit more interesting. We have the group control code, which does the the communication on very high layer, and then we have the data distribution layer. The data distribution layer is the code that actually is responsible for distributing the image and annotation data from one peer to all the other peers. And for doing it, we use another layer that we call remote object invocation. And this remote object invocation layer allows us to use object-oriented remote function calls to communicate with other instances within our communication group. This is very similar to Corba, with one exception. Corba communication, where you have the possibility to have remote objects. You can call methods within this remote objects with Corba, and you have to address a single object for this method call when you use Corba. And what we want to do is that we want to perform these remote method invocations on a group of objects. So we have a group of objects which are the different whiteboards within the conference, and we want to do a method call in a group of these remote objects and get the information back. And this is done via this middleware we have developed in Hannover, the remote object invocation interface. This middleware has the possibility to use very different transport protocols. Of course, we are able to have unicast or peer-to-peer protocols and peer-to-peer operation of this this middleware. We can use, of course, TCP and various UDP styles. We have standard UDP unreliable connection. We can do it, we can make it reliable with some overhead or rate limited. The interesting thing is this IP multicast. We can use unreliable UDP with IP multicast, or we can use one of these two reliable multicast protocols. In the whiteboard, for example, we use the Lightword reliable multicast protocol, LRMP from Annover, France, to get reliable transport over multicast connections. And the thing the whiteboard in this scenario really uses is the multicast simulation. We have a central server. The central server uses a TCP connection from the peer to the server, and this TCP connection is tunneling all the data that runs normally via unicast or multicast traffic in that case. So the central server is able to route these messages in the case of multicast, or to distribute the messages in the case of multicast to the peer that needs to get the actual method invocation data. It is really important, if you look at the firewall scenario, that we are tunneling all the data through this one TCP connection, so that the firewall administrator can check this central server in his firewall and allow connections to it. And there are no other connections if someone uses our whiteboard. Of course, we have some semantics that are for our method calls. The first two semantics are the same as you will find, for example, in Corba or in RMI. We have normal calls that are unicast only, that are method invocations of remote objects, and these calls are synchronous, and we get the result back. We have so-called one-way calls. One-way calls need not to be synchronous. They are sent to the remote object, but the caller does not wait for the execution of this call, so this call often is called as unreliable. And of course, there is no result of this call. And we have two other semantics. That is the reliable group call with one return value, where we select the first return value of the returns of different objects, of the object measure invocation, within our communication group or our object group, and we can do the group call and get the full result vector back with each value. Okay, I think I skipped this slide because we are short on time. The conclusion. We have developed a multi-user whiteboard which uses a group-oriented middleware, our remote object invocation middleware, and which is based on the Java imaging API. We are using this whiteboard in a medical context, and there are some links. The first one is in German, or has German information. So if you want to read more about the project, please follow these links. And what we will do in the future is, of course, that we try to get a better adoption and a better integration into the medical environment of this whiteboard. And we want an integration of this medical surgery planning software into our whiteboard so that it would be easy to get the image data into the whiteboard. Of course, there are some things with the user interface, input file formats, and functionality that is missing, which we are going to add in the future. And a very big point at the end is security. As we are doing a pilot project, security is not a real issue within this project, but everybody knows that this data is transmitted on insecure means. But if you try to get this system into production, of course, security is a big issue. We have to add security to the video data communication. We have to encrypt the audiovisual data streams, which is a big challenge. And, of course, we have to add security and encryption features to the whiteboard. But this would be very simple using the standard techniques like SSL, etc. Okay, thank you so far. And yes, if you have some questions.
Thank you very much, Mike, for Has anybody got any questions about this interesting use of electronic whiteboards? There's speaker up, questions up there. I think the technology on the video conferencing has gone wrong because Michael and I are seeing something totally different now on the screen.
Yes.
Hello, I'd like to ask how the surgeons like this project, what's their feedback, and how do you organize their work remotely? Thank you.
Well, nice question. The consultations of the orthodontists and the surgeons are taking place with face-to-face meeting right now. So that these meetings are done by several years. And what we want to do is to do it by a video conference. So if you look at the work schedule of the surgeons, there isn't any change. The surgeons we have in this project are very able to use this modern kind of communications like video communications, etc. But of course, if you want to bring the system into production, there has to be a training phase for the surgeons and for the orthodontists.
Any more questions? No? Thank you very much, Michael.
Thank you.
Our final speaker in this session is Thomas Schmidt. Thomas is the head of the Computer Centre of FHTW Berlin, and since the late 1980s he's been involved in many computing projects, especially focusing on simulation and parallel programming. His current fields of interest lie in the areas of networked multimedia applications and tele-learning. Thomas is going to speak about global serverless videoconferencing over IP. Thomas.
Yeah, thank you for the introduction. Hello, everybody. We have in this session we have heard something or many interesting aspects of efforts one has to take in order to build up video conference infrastructures. And I will try to take the opposite view. I will try to report on work we are doing at our institution to establish video conferencing without any infrastructure, additional infrastructure. This joint work with Matthias, who is here, and with our video codec group. If we look at communication applications in the internet, we see that the killer application is still email. This is, we believe, is because email is first of all, unique to computer networks. It is the only asynchronous communication system which works within seconds. We have nowadays SMS, but okay. Email today is reliable, is mature, is easy, free, everybody can use it everywhere. Yeah, so it makes it very popular, and especially email has full infrastructure support. So we think about video conferencing. What about that? Well, the good thing is video conferencing is to some extent, you can say, unique to computer networks. This is not quite true. You have ISDN-based systems, and they are still in operation, but they don't spread. They're expensive. People don't have them. In the IP world, video conferencing is today is not really reliable and mature, but you have quite good solutions. You can use video conferencing, as we saw here, but it is not at all easy and free. It is not at all accessible everywhere. It is expensive to build up the systems, and video conferencing does not have full infrastructure support. So if we believe video conferencing will be or should be a killer application in the future, well, we should do something there. We should make it easy, free, accessible everywhere, and sort of integrate it in infrastructure. So that brings me to the outline of my talk. First, for introducing the topic, I will recall the communication paradigm, the specialities of video conferencing. I will shortly discuss where are we now, where are we going presently, and then I will introduce to you our project, which is first of all consists of a distributed communication scheme for locating people, doing group conferencing, and I'll introduce to you the video conference software that implements it, which is called Davico. It has some nice properties, and yeah, then we come to the conclusions. Video conferencing has trivial property that it is session-oriented, that is a synchronous service, and at the same time it is user-oriented. I want to speak to, or I want to communicate with a person and not with a device. This is a bit special for the IP world. Usually we have session-oriented services on the basis of machines like standard applications for terminals or so. Video conferencing, of course, is in a situation of, well, having to address mobile users. You have to, if you want to talk to someone, you need to find them on a global basis. And it's also, well, it's normal to have group support. It's good to have group conferences, and which is probably will become more and more important. You need to support for privacy, for authentication, at least if you want to do, well, serious communications about it. Well, what is a bit provocatively spoken, the situation today? The serious conference applications you have in whatever headquarters of countries or companies are based on ISDN. You have conference rooms, you have ISDN channels, and well, people use it, but this of course doesn't spread. We have heard a lot about today about the IP solution, the IP H323 solution, which is more or less an ISDN transformation into the IP world with server infrastructure of MCU gatekeepers, which is expensive, as we, well, sort of heard, which suffers from scaling deficiencies, which has the problem of at least the MCUs putting additional latency to the conference. And, well, you have sort of a strange situation with the addressing you're using, or it's not strange, but it's strange for the IP world. You're using telephone numbers, which is, of course, obvious if you want to be compatible with the ISDN world. Well, and you have the, first of all, with the gatekeepers, you have a local relaying technique, which can be extended to hierarchies, and you have meta directories then with all problems related there. Well, the good thing about H323 is that it is conformal with ISDN systems and that you can address people from telephones and vice versa, but the bad news is, at least in our point of view, that the ISDN video conferencing does not really spread, so the motion of rolling out video conferencing should come from the IP world. Well, there's an IP ansatz, the session initiation protocol, which is not widely implemented, and it is, well, it is in some sense complicated from the infrastructure point of view, or at some point rather vague. It also brings a specific addressing scheme. Well, then, of course, you have proprietary services like the Internet Session Locator from Microsoft or so, which is centralized. Yeah, so where are we going? Are we going at all? Well, we see here, and we have that in Germany from the DFN2, we see the building up, we have that in SurfNet, the building up of H323 infrastructures, and well, I believe at least in Germany, it's quite not decided who is paying for it in the future and who is really using it. There is always the danger of producing dead-born childs, which future will show. At least we have the problem with H323 that it fights the inertia of infrastructure. We have to change infrastructure a lot. We have costs. We also have this sort of inadequate, from the internet point of view, inadequate solution that we have, yeah, to address either telephone numbers, or we have to sort of agree on gatekeepers, MCUs. We have to apply for conference sessions, like we have heard in the former talk. And this is basically, to our feeling, an insufficient communication support. If I sit on in front of my PC, I might want to address, well, some colleagues somewhere, and what I want to do is something like I use email. I want to address this person right away. I want to find him. I want to talk to him if he is online. Yeah. This is a bit what we think should be an internet-like approach. To put it into more technical terms, should be more lightweight, should be not centralized, should be an end-to-end model. And, well, we are trying to, well, build this up. Yeah. What are the recipes? The recipes are stick to an easy, intuitive solution which is close to what the communication paradigm is, what the user's approaches. Provide addressing. We need addressing. It should be personal addressing. It should be more or less effortless. It should be made of known addresses. Well, if you have addresses, you need to find the user. You need to provide an automatic user location. And what we believe is very important, remain rigorously neutral to infrastructure, because, well, change is very hard to achieve. It's expensive and not always possible, because you're not always in the situation of having control of the infrastructure. Well, cost is a problem. And what is, I believe, also very important is find distributed, decentralized services to avoid scaling problems, to avoid also administrative overheads you can't really handle. Think of knowing people, think of putting data, personal data, into gatekeepers or so. Yeah, and stick to the internet paradigm. Well, how do we start out? What do we do? We take email addresses, which is not too too strange, which is rather obvious because they are first of all well known. Everybody knows them. They are globally unique, and what is more important is that they are suitable for what we need: automatic relaying, automatic user location. This is because email is very well supported by the network information systems like DNS. Well, we follow the peer-to-peer principle, point-to-point, point-to-multipoint, via multicasting. This is, of course, as we heard, sometimes a problem, because multicasts are not really supported throughout the networks. There are also problems with the DFN multicast, but other providers don't support multicast at all. So what we also do, which is usually groups are not so big, we do n times unicasts. Well, what we need is sort of information services, but we try to hide them, and they are in a distributed setup. They are not centralized. There's no central data storing. And what we also do is it's a pure software solution. There's no hardware involved except for the webcam. So, problem of user location. What we need to do, what probably everyone needs to do, is you need to get the information of where your user is located at the moment. So, well, you need to map the user's identifier, the user's email address on the current device he sits on. And, well, this is an application for a directory server. We use LDAP. But the point is, this directory servers in our ansatz are local to your domain. They're small. They're hidden. You don't see them. You don't feel them as a user. And okay. And the problem then reduces to finding the directory server. They are distributed. If they are somewhere, if we are talking from here to some guy in Asia, we probably don't know anything about his infrastructure, so we need a scheme to find his directory server. And what we pick is the DNS MX record. We are using email addresses, so we can resolve the MX record, and then we do a simple name convention, changing a name to USL at MX domain. This is due to the fact that there's no service record in operation in DNS now. There's, of course, an RFC for a service record, but normal DNSs don't employ them. What you have then is you have a decentralized administration and authentication, because in the email domain, of course, users are known. They are administered, they are known, they are able to authenticate. Well, how does it work? And from the picture point of view, well, the picture is you have someone, Snoopy, coming in his house and going online, starting his PC. What he does is automatically he finds out about his directory server and registers his session, because he's online now. He starts the software. So once he has done this, he's addressable. Well, and in this case, someone else, Charlie Brown, wants to talk to him. And what he does is he knows his email address, so he can find out via the DNS where his directory service is, looks Snoopy up, and then can initiate a video conference with Snoopy. Well, both people have to do is provide email addresses, and they don't have to do or to know anything else. Well, one well, you need a directory scheme. There were some discussions about it, also in the literature, which are mainly due to the fact that if you do centralized services, you need sort of something which scales well. We don't need this. We don't have a problem. What we, of course, need is directory scheme. We wanted to achieve two things. First of all, we want to provide a directory tree which easily fits into directories people or institutions already have. And then we need some informations. Well, unavoidably, they are required, which is host number, port number, protocol, timestamp to expire sessions, the mail address, of course, and for convenience, the common name. And there's also an optional scheme, especially MIME types to handle codecs and application IDs and so on, multicast groups, STATI, and also we'll come to this private IPs for this NAT problem. Once again, we use LDAP, and LDAP supports authentication and also encryption, which is good for privacy. Yeah, the problem with NAT, well, we heard about this, I believe, every day in every session. Yeah, NAT is a problem for everyone who wants to address someone else, and we strongly hope that this will vanish, disappear with IPv6, but nevertheless, today we have NAT, and we can't really go away from this. We don't want to apply application layer gateways like they are available for H323 because this is also a change to infrastructure. You need to implement them on the NAT gateway. So what do we do? It's a standard workaround. We position this session locator outside the NAT range. Well, we need some position outside the NAT range, otherwise we wouldn't see the public IP address. And well, we sort of have to take care that the NAT gateway doesn't drop its state informations. We use, well, what we are living off is that we communicate through the same channel. Through the same channel in and out to the same port. Well, once we did so, we can extract at the directory server at this LDAP server, which is outside the NAT range. We can extract from the IP headers the address and the port, and we can publish them, and then you get addressability. Yeah, some words about video. I will do it quickly. Some words about the video conference software which implements this model. It is a pure software solution, runs on a standard PC. I give you some numbers next. It does multicasting. It also does n times unicasting. It relies on a present-day proprietary, highly efficient video codec, which is well, presently not comparable to anything. It uses Mpeg 3. For audio, it has in the present stage, it has a buffer latency in the audio of about 100 milliseconds. It supports application sharing, which I forgot to say is, of course, one of the strong arguments for video conferencing over IP. And, well, it is designed for just easy use, best effort, and, well, a low latency, low bandwidth by client implementation. Well, the good thing about it also is the video codec, a wavelet video codec, which is, has first of all the property that it can run in software on the machines. It has for the CIF format and 25 frames per second, performs in real time on a 500 megahertz Pentium machine, and it has data rates usually below 200 kilobits per second. It is more efficient than Mpeg 4 or H.263. Well, and then it has the nice feature which wavelet codecs always have. I will skip this, the principles here. It has the nice feature that you always encode the whole image. If you compare, this is the original image, this is JPEG image, then you see blocking artifacts here because, well, this is the way JPEG works. Wavelet always transforms the whole image, and therefore it is a layer of frequencies, and therefore all you see is there's, well, in this strong changes in the image, you see some unsharpnesses, but, well, I believe from behind it looks like the original, even though it has a compression rate of 64. Yeah, to give you an image, well, our goal was and still is to roll out the conference software, to easily roll out, to give it to everyone in our campus in this case, also to give it to people who are able to video conference from home. Well, they need a DSL. It's not, it is, well, there's a codec that runs on ISDN bandwidth, but, well, it is not really suitable for good video conferencing. So this gives you an image of the software running here. It's a bit dark. And also the setup we put in our university to just have public places, video conference ready. And we hope, we started this 2 months ago, so we hope it will be very popular. So let me come to the conclusions. What I tried to present to you was video conferencing over IP solution which is, of course, away from standards, which is lightweight, peer-to-peer model, does not care about the burden of history. It is neutral to infrastructure and ready to use, including addressing scheme and user lookup. Well, in the future, we, well, of course, want to continue. Want to come a bit more close to standards. One of them would be the codec. The codec will be, or a future version of the codec will be part of the E2 standard H.264, or they came together with the Mpeg group, and it's now called Advanced Video Codec. And well, as I mentioned before, the user directory service are better placed or better identified via a DNS service record. Which we hope to be rolled out, which we hope to become operational in the DNS in future. Yeah, thank you very much.
Thank you very much. We've got time for a few questions. Any questions? One there.
Let me say that this is a very interesting approach, and I would like to discuss this a lot further with you. Now, as one of the people that set up H.323 services and is actually doing some work in making this internationally work, and working with vendors to make H.323 more IP and internet-like, I do feel that I have to comment on some of your basic premises where you're going. Using email addresses as the address that you want to type in is a great idea. But that's exactly what is happening in SIP and 323 at the moment too. They now have the H.323 URL and email-based dialing and DNS support, which is a new H.323 annex, part of the standard. SIP does the same, and yes, you do need DNS servers records, but they can be implemented, and they are implemented at a lot of spaces. The standard tools you get with Linux now do support that. So the addressing part is one thing. Now, the numeric addressing part that you can still use in 323, which you think is not interesting or not normal, people do remember telephone numbers. They do like telephone numbers. You can look them up in directories all over the world. And you can even dial normal telephone systems. How do you do that?
Well, of course we don't. This is what I said in the beginning. The great thing about H323 is that it is compliant to the telephone system, that you can talk with people who are using video conference systems from the ISDN world, also audio, of course, telephones, simple telephones. But, well, our approach is, or our observation is that, at least from the video conference point of view, the ISDN systems don't really spread because just, well, for obvious reasons. And so it is not, well, for our approach here, it is not really interesting to look at that.
One more question. The USLs, the user service location, do you expect users to set them up, or do you expect the network people, the network managers within the institutes to set up these kind of services?
Well, this is either way. All you need is well, a simple host and a DNS name for that, an A record. You can use it up as set it up as a user, if you like, or you can provide it as a network administrator. It is open.
And then a change in the DNS server.
Well, you need an A record for the host. If you, it's like if you bring another host in with a name.
Okay. Any more questions? No. Thomas, have you got a URL that you can tell people where the software is?
There's. It's also in the papers. There are two URLs, but there's a URL for the video conferencing system. Especially, it is www.davico -gmbh.de.
Well, thank you very much to Thomas and to all our speakers in this session. It's now lunchtime, but can I encourage you to come back just before 2 o'clock so that people can make prompt starts again at 2? Thank you very much.